All right, today we're going to be finding area of trapezoids rhombi and kites. It's an R. Trapezoids, rhombi, and kites. All right, so area of a trapezoid. That's equal to 1/2. 1/2 of the height, or 1/2 times the height, and then you multiply that by your base 1 plus your base 2. 1/2 times height times base 1 plus base 2. You got to add the bases together first. So look, in a trapezoid, the bases are the parallel sides. Let's see. The height of a trapezoid, quadrilateral, exactly one pair of parallel sides. Okay, so the parallel sides, top parallel to the bottom. That makes this. It doesn't matter if you call the top base 1 or base 2. All right, we're going to call this one. We'll call this base 1, and we'll call the bottom one base 2. The only thing that you have to be sure to do is use the parallel sides as your bases. Yeah. Your height, just like yesterday, is always perpendicular to the base. Base and height are always perpendicular. Okay? So it's just a matter of finding some values and plugging them in. If you got a 28 up here and the bottom's 38 and your height is 10, in its simplest form, your area is equal to 1/2 times 10 times base 1, which is 28, plus 38. So 1/2 times 10 is 5 times 28 plus 38 is 66. And 5 times 66, 330. So there's your area. Now let's do one where they make you do a little more work. So let's see here. All right, so we got this whole side here is 10. We got L. We got an X. We got another X. We got a 4. And another 4. And here's your perpendicular side, or dimension. Find the area of the shaded. Find the area. So we are going to find the area. And I got one more dimension. This is 8.5. Okay, so looking at this, you're missing, here's your base 1, right? This is your base 2. Here's your height. Got it? So look, here's what you got to do. If the area equals 1/2 height times base 1 plus base 2, if we find this L, which you have the most information to find out, if you take 10 minus L, won't that give you X? And if you have X, you got your base 2, right? So look at this shape right here. What kind of shape do you got right here? You did this yesterday. Yep. What kind of triangle? A right triangle. So can't you do the Pythagorean theorem to solve for L? So we would have L squared plus 4 squared equals 8.5 squared. So we can subtract 4 squared from each side. So L squared is going to equal, in your calculator, you can type 8.5 x squared minus 4 squared, 56.25. And then you would find the square root of each, 7.5. So that's your L. So your X would be equal to 10 minus 7.5. And what's that? That's 2.5. So now our area is equal to 1/2 times the height. What's the height? 4. What's base 1? And what's base 2? 2.5. Good. So 1/2 of 4 is 2 times 10 plus 2.5. Good. And what is 2.5 or 12.5 times 2? 25. So there's your area. All right, and you could also see problems just like you saw yesterday where, you know, one end of this trapezoid is a 30-60-90, or it's a 45-45-90, and you have to use your rules about special right triangles to find the height or to find a piece of one of the bases so that you can find the other base. Everybody give trapezoids? Okay. So now we got rhombus or kite. Same formula. Area of rhombus. Ooh. Area of rhombus or kite is equal to 1/2 times diagonal 1 times diagonal 2. All right, let's draw a picture of what a rhombus and a kite looks like first. So here's your rhombus. In a rhombus, you've got, no, let me just do this here. It's easier. All the sides are the same. All right, there's your rhombus. Kite. Kite's got two pair of congruent sides. All right, rhombus is just like a square, but it's pushed over, right? Doesn't have 90-degree angles. All the sides are the same. Kite has two pairs of congruent sides. All right? Consecutive congruent sides. Let's write that down. Two pairs. Consecutive congruent sides. Means they got to be next to each other, right? They can't be across from each other. That would make it like a rectangle or a parallelogram. Now, in this rhombus, all right, this dimension right here, here's your diagonals right here. There's one diagonal. Here's the other one. Make your picture, make it hit that vertex right there. I still missed it. Son of a... There. All right, so here's your diagonal 1, which makes this diagonal 2. In the kite, right here, here's one of them. And here's the other one, vertical. All right, so here's D1, here's diagonal 2. Now, in a diagonal or in a kite, in a rhombus or in a kite, diagonals bisect each other. Check that. They don't bisect each other. In a rhombus, they do. So let's just make a note here. Rhombus, the diagonals bisect each other. So what that means, see where let me put this green, see the green section of this diagonal? If it's equal to 4, then what's this green section equal to? That's equal to 4 as well. Okay? So what's that whole diagonal there? It would be 8, wouldn't it? And this piece, go blue. If this piece right here was 6, then what would this other blue piece be? It would be 6. And what would that entire diagonal be? It would be 12, wouldn't it? All right. Yes, ma'am. Say that again.
If all the sides are equal to each other,
It's a great question. If all she said, her question was, if all the sides are the same, wouldn't the diagonals be the same? And I don't have.
And also, how did you get 12?
6 plus 6 is 12.
Oh,
It's okay. Let's see. Hang on a second. Let's look at. I'll try to answer it with a drawing. Okay. This picture right here, where all the sides are the same, it appears as though the diagonals are congruent, doesn't it? God, I wish I had a box. I need a box to show you this. Because what's going to happen as that... no, I need like a cardboard box real quick. I'm not going to be able to find one. It's got all the same sides.
right? It's like all the same time. It's like same time, right? You go like that. They still like you go like this, right? It's still the same.
Explain it to you yet? Well, no, it's a great question, and if I had a box.
What happened with the box?
It needs to be a cardboard box where I can disconnect the top and the bottom, and you could start it looking like the picture that we had, but then if you take it and you really do this to it, if you really slant it, right? And if that, and then I'm back to here and I'm back to here. See how those are pretty close to being the same length? Okay, so when all the angles are 90 degrees, it's a square and the diagonals are congruent. But as soon as you start to tilt it, and as soon as one angle isn't 90, then the diagonals aren't congruent anymore, and it's not a square, it becomes a rhombus.
Wait a minute. She said okay, but I'm still confused. Because when you compress it, like you see how
as you compress it, you can see that this.
Those two sides are getting closer, and the other two are getting farther away.
Yeah, blue. As you compress this thing, blue is going to get greater than green, isn't it? And as you keep to compress it, the sides are going to stay the same, but blue's going to get longer and green's going to get shorter. Okay? But each side of blue is still going to be equal to each other, and each side of green will still be equal. Right? Make any more sense? It makes sense now, doesn't it? Yeah. That's why it was a really good question, because up here, when you look at that and you go, well, all the sides are the same, the diagonals are the same. They are when all the angles are 90. Then it would get taller again. It would be more like this. Yeah, what he said. Well, most of you understand it, right? Okay. The diagonals of a rhombus are not congruent, but they do bisect each other. Okay, so diagonals. So let's take a look at this. Kind of like you did yesterday, you're going to have some problems where you're going to be told the area is 92. Area equals 92. And then you get a kite on its side. And it's got 22. And x. And we're going to say this is a kite, so here, 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 here. So what's the formula for the area of a kite? Look, when you get these problems, here's how I told you to do them yesterday, and it stays the same. It's 1/2 diagonal 1 times diagonal 2. So the first thing you do is you write down the area formula. Area equals 1/2 times diagonal 1 times diagonal 2. Well, you can call the 22 D1 and you can call the X D2. Those are your two diagonals, right? Those dimensions represent your diagonals. So then substitute. So your area, which is 92, equals 1/2 times 22 times X. So 92 equals, what's half of 22? 11 times X. If you divide both sides by 11, $8.36 equals X. Everybody all right with that? All right, and then let's do another one with a trapezoid. A little more complicated formula. So let's say the area is 177. And here's your trapezoid. We got an X, we got an 11. We got a height of 13. And you got to solve for X, or you got to find X. So what's the formula for the area of a trapezoid? Very good. Now, look. When you're starting to get multiple data points, label them. You've got your area. What do you want to call the X? B1. And what's the other one then, the 11? B2. And what's the 13? It's your H. So now substitute. You got 177 equals 1/2 times the height, which is 13, times base 1, which is X, plus base 2, which is 11. So 177 equals, what's half times 13? 6.5 times X plus 11. Now this is multiplication. It's 6.5 times X plus 11. So you can divide both sides by 6.5. No, you can distribute, but you don't need to. You save time by dividing. So 27.23 equals X plus 11, and then you can subtract 11. $16.23. All right, so any questions on anything we talked about today? That's finding the area of trapezoid, rhombus, and kites. Good, good. Questions? All right, your practice for today. Page is 141 and 142. All problems. All right. If you're in class, they're going in the basket.